point of intersection is a pair of coordinates which will work for two or more equations of curves or lines. So saying that for these equations, there is an x value that works for both that gives the same y value for both. Now, usually trying to give that description of a same x and y working for two or more equations, that may usually get you to think about simultaneous equations from a more just equation-based standpoint. However, here we may also start to look graphically. Starting with the simultaneous equations though, just to make sure we are happy with those as a starting point, we may have something like this, wherein given that the following has equal roots, solve 2x plus y equals 1, and then x squared minus 4ky plus 5k equals 0. Now this is slightly different already from perhaps what simultaneous equations you are used to. At GCSE you would usually again have your x and y, and because there are two unknowns you can't solve immediately, so you have to eliminate one of them. So you times the equations until the coefficients of one of the letters are the same and you take them away from each other. Or you learn to substitute if one of them is a quadratic equation and the other isn't. Here now we have another unknown thrown in there as part of the whole numbers, as part of the coefficients. But we're also told on top of that, this piece of information, that they have equal roots. Now the idea of equal roots is something we're going to come across more and more as we go through this video, but it's the idea that you would only have one solution essentially, or rather there are two solutions but they're the exact same value. So we're only looking for there to get one value of x out of this and one value of y, despite the fact that this is a quadratic. So what we will have to do to try to solve these is substitute one into the other, because this is a quadratic and this isn't. So what we could do is rearrange this top equation to make y the subject, leaving us with 1 minus 2x, and therefore we can replace this y here with that expression. So it will become x squared minus 4k times by the 1 minus 2x plus 5k equals 0, which here, if we just expand the brackets, you would end up with x squared minus 4k and then plus 8kx plus 5k equals 0, because the minus times the minus becomes plus. Then, bringing the like terms together, we'd just get that x squared plus 8kx plus k equals 0. Now, if we were then to solve this, if we know that the simultaneous equations are only going to have one solution, then we shouldn't be finding multiple values of k, because then if we have multiple values of k, we'd have multiple interpretations of this second equation here, you'd end up with multiple valid answers. So if there's only one set of solutions, there's only going to be one value of k as well. So if you were to attempt to factorize this just algebraically, put this into two brackets because it is a quadratic, you should find that not only do both brackets start with x, but both brackets end with the same value as well as having the same sign. They'd have to be identical with each other exactly to just give the one same solution. Well, what two numbers would times together to make k? Well, that would be the square root of k, both here and here. And then because it's going to be a plus 8k in the middle, these need to be both plus and plus. But if you were to expand these brackets right now, you wouldn't get back to this original. The middle term would end up being 2 root k, lots of x. But here you're supposed to have 8k in the middle. Well, nonetheless, we know it has to end in root k to times together to get a single k here. Therefore, we can say that 2 root k is indeed equal to 8k. So if we're now just to divide the 8 over this side, so 2 divided by 8 would be a quarter. And then k divided by the root k leaves you with just another root k here. So if a quarter is the square root of k, then k itself will be a quarter squared, which is 1 over 16. Now that we know what k is, we can return to this quadratic here and now solve for x. So we're going to say that's now the same as x squared plus a half. X, because 8 times 1 over 16 is going to be the same as half, and then plus 1 over 16 here equals 0. If you wish, you could times this all up into integers to make it easier for you. So you times up by the biggest denominator, which is 16, so that will become 16x squared, and then a half times 16 will be the 8, and then this will just be plus 1 at the end. It's fine to do this because you're changing every single term by the same factor, even the 0, because 0 times anything is still going to stay 0. This, because it's all in integers, may be easier to factorise, so we can break it down into two brackets. Again, we're expecting only a single solution, we're expecting single roots, so we're trying to get these brackets to be the same as each other. Well, what times this together to make 1? It's just going to be 1 and 1. And to make 16x squared, we'll have 4x and 4x, with then finally just the plus in the middle. And to double check, the 4x times 1 is obviously 4x. 1 times 4x is 4x. Add those together. Yep, that's now the 8x that we had in the middle. So, therefore, if 4x plus 1 has to equal 0, then x itself would be minus 1/4. And you can double check if you want by plugging that minus 1/4 back into this quadratic up here, and yeah, you'd find it equals 0. And then, now that we know that that's what x equals, we can therefore say that y is going to be 1 minus 2 lots of that from what we had above here. So that's going to leave y being 3/2. Once again, if you wanted, you could check this because we know what k is. We know k is a 16th. So if you want to plug in the x as minus 1/4 here and the y as 3/2, k is 1/16. Remembering, if you do this, that the minus 1/4 should be in brackets first before you square it, you would end up, once again, yeah, with 0, showing that that's correct. So, yes, this is the perhaps more traditional way of finding what x and y values work for two or more equations, that being simultaneously. However, now, for points of intersection, which usually refers to graphs, we may have to sketch and look at the diagrams for the solutions instead. So here, we are asked to sketch the lines y equals x in brackets 4 minus x, and x equals x squared in brackets 7 minus x. The reason why they've given them to you into this factorized form, why that's beneficial for you, is this gives you the roots, it gives you where they're going to cross the x-axis. Because we can say here, these are two things times together. When you cross the x-axis, your y equals 0, so two things times together to equal 0. Therefore, each of them must be 0 in itself. So we could say here for this first one that it will cross the x-axis at x is 0 and x is 4. Similarly here, we could say that, okay, if x squared is 0, x is 0 as well. And then here, if the 7 minus x is 0, then x will be 7 to make it cross the x-axis. If we're also just to expand, though, you'd end up with 4x minus x squared, and then here 7x squared minus x cubed. This here shows us that the first equation is going to get us a negative quadratic. So it's going to be like this N-shaped, this upside down curve. Here in general, if you have a positive x squared, that's going to make you like a positive parabola, a U shape. Negative x squared will give you an N shape, a negative parabola. If you had a positive cubic, that's going to give basically start off going right to left with the quadratic, but then come down again. So it's going to go up and down like that. And then the negative quadratic, same again. So take the negative quadratic and then curve up again. So negative cubic here, starting, going down, then coming back up again. They're the reverse of each other. So here, as I say, because we can see this is a negative quadratic, it's going to be its N shape. We know that it crosses x is 0 and x is 4, that says about there. So this curve is going to look something like that. It's a sketch, so it doesn't have to be too precise. We just want to specify that's a 0 here, that's a 4 here. Now, as for the cubic, again, we're saying it's going to cross at 0 and it's going to cross at 7, which might be about here-ish. And because it's a negative cubic, it's going to have this kind of shape here. Now, with this being the square here, technically that is a double root, there's an equal root of x being 0 and x being 0. So, what we say is that is where the turning point will be, where it cuts the axis here. Here we'll be coming down and then coming back up again here, rather than cutting through the axis per se. And then that will cut through the line here, we'll go up for a little way, we don't know how far, then it will come back. This is also why there is only 2 points of intersection on a cubic graph, where in theory, like if the axis had just been somewhere up here, you could have had anywhere up to 3 points of intersection. If you've got a square thing here, we're saying we've got x, x in the bracket. So again, just to repeat, that's like a double root at 0. It gets down to the curve, but then goes straight back up again. Now, for the points of intersection, we can say there's going to be a point of intersection, therefore obviously at 0, because both of them were going through that point. We can see there's going to be some point of intersection here. But then also, if we had just been able to continue the lines down this way, we would find there is some further third point of intersection all the way down in the negative region. Well, using this, we would like to therefore find the positive point of intersection. Let's say though, there's 3 points, which one is the positive? Well, at 0, 0, that's kind of neutral, that's neither positive nor negative. This one up here is obviously both positive, and this one down here, even though the x is positive, the y is negative. So yeah, it's this one in the middle that we're going to be looking for. As to how we're going to find it, well, we can start by setting these two equations equal to each other, because if it is the same x giving the same y, then this y will be the same as this y. So yeah, we can say that your 4x minus x squared equals the 7x squared minus x cubed. If we now bring the right hand side onto the left to make the biggest power positive, you'd have x cubed, then minus 8x squared, because this can become minus 7 to what's already a minus 1, and then your plus 4x equals 0. Now, in order for us to go about solving this, well, we could, in theory, solve a cubic. What we can actually do is, first of all, factorize out a common factor of just x, leaving us then with your x squared minus 8x plus 4 equals 0. So first of all, this already tells us that the x being a factor is that 0 is going to be a root. Well, I mean, yes, we can already see that. We knew that one. It's not the one we're looking for. And that leaves us then with a quadratic, which we can more easily solve for 2 solutions, one of which will be here and one of which will be the x-coordinate here. This does not nicely break down into 2 brackets, so we will have to use the quadratic formula, where our a is 1, our b is minus 8, and our c is 4. So we're going to have, so minus b, so minus 8 is going to be a positive 8, plus or minus the square root of minus 8 squared minus 4 times by our 1 times by our 4. And this is all going to be over 2 times the 1. If you put that into your calculator, you're going to get 2 solutions for that to add on to what we had before. So we already know x is 0, but now we can also say that x is 4 plus 2 root 3 and 4 minus 2 root 3. As I said, we're already going to eliminate x being 0 as the root that we're after. And here, the root that we are after is the one in the middle, or it's the one to the left out of the pair. Well, of these, the smaller value is the 4 minus the 2 root 3 here. 4 plus 2 root 3 is bigger, that's further to the right. Again, not the one we're after, so we're going to ignore that one as well. So, now that we know that this is the x-coordinate of our point of intersection, and again, even though there's a minus here, you would find this is still a positive x value. If we can now just plug that back into either of the earlier equations, it doesn't matter which, I'll just pick the first one. So y is going to equal 4 minus 2 root 3 for that x, and then that's times by 4 minus the 4 minus 2 root 3 again. Putting that into your calculator, you then find that your y coordinate would be minus 12 plus 8 root 3. And again, even though this has a negative in it, you would find this is actually still positive in a decimal form. So yes, that is the positive y value that we would be expecting here. Okay. So if we can see then how we can treat equations simultaneously potentially to find solutions, whether we're substituting or making them equal to each other, and then also how we can sketch our curves to kind of visually represent the point of intersection, let's just see how you might get along with an example of your own. So the point 1a lies on y equals, then the first brackets is x plus 1 squared, and times by, in another brackets, 2 minus x. Given this, find a. Then sketch y equals that, well, that whole equation with the brackets, and also the graph of y equals 2 over x, and then state the number of real solutions. Okay. So consider what you might want to do in order to find each of those pieces of information. If you're not sure what a graph is going to look like, it's always a surefire way to just plug in some x values, get out some y values, and then just plot those coordinates and see what shape of a graph that starts to get you. And then yes, think what it would mean to just find the number of real solutions for the points of intersection. What do we mean by that? Pause the video, have a go for yourself, and then press play again when you're ready to compare. So if we know that this coordinate is on this graph, then what we can do is we can plug in the x coordinate here of 1, and we know that we should get a y coordinate of a out afterwards. So if your a is going to equal 1 plus 1 squared and times by 2 minus 1, well, 1 plus 1 is 2, squared is going to be 4, and then 2 minus your 1 is 1, so 4 times 1, that's just going to get you a value of 4. Then, if we are going to sketch these curves here, what we can say is, once again, because this is in a factorized form, we can work out where the line is going to cut the x-axis. We can say that, well, what x would make this bracket equal 0? That would be minus 1. So there's going to be a root here. Well, not only is there going to be a root, there's going to be a double root because it's squared. Okay? And then this one is going to be when x is equal to positive 2. Okay, so that's going to be somewhere up here. Now, you don't have to expand this entire thing if you don't want to, but what we probably want to recognise is if we did, you'd end up with a negative x cubed at the start, and then would end with a 2 here. So we know what the shape of this graph is going to be. We're going to start by coming down here, and go up, and then go back down through here. And again, we know this is the double root here, so we're just going to turn at that point. We also know that we're going to cross the graph at 2 here, because this final value here on its own, that's the y-intercept. So just to sketch that on, going up here, go on here, and we'll turn some point later and come down here. So that's your 2, that's your minus 1, and that's your 2 as well. Now, as for y equals 2 over x, these kind of graphs here, they're always going to be starting near the y-axis and the right-hand side, really steep, but then as soon as they become shallow, and what they're going to do is they're going to tend towards the x-axis here, but it would never actually reach it. Then the same happens in the bottom left quadrant. We're going to start near the y-axis really steep, but then we'll level off, getting closer and closer to the x-axis, but never getting there. The reason for this is that the bigger the x becomes, the smaller this value of y is going to become, but a positive divided by a positive is never going to give a negative answer, nor is it going to give 0. So we're never going to reach the axis. But then the smaller the x is, the larger and larger this fractional value gets, so we're going to get into massive y values up there. Now, once again, if we just want to identify the points of intersection, the real solutions to both of these equations here, we say, well, there's a solution here and a solution here. The graph for the cubic is never going to come down into the bottom left quadrant here, so it's never going to cut the 2 over x on that side, and from this point, these two lines on the right hand side are never going to touch again. And then actually, if you were just thinking, how do we know that even these 2 points here exist? How do we know that the cubic goes up high enough to cross through the 2 over x, or that the 2 over x goes low enough to cut through the cubic? Well, either if you've, actually just plotted the points on yourself, like worked out, okay, for this x value, the y is this, and we know it's there, and you can just see from the coordinate you plotted, you see they make that shape. But also, if not, if we did just want to verify, let's pick an x value that's somewhere between here. Let's say we picked that x was 1. Well, on this line here, 2 divided by 1 would leave us level with this point here, that we would have y being 2. However, from the beginning of the question, we know that when x is 1 on this curve, you have the y coordinate 4. Therefore, the cubic graph is higher than the reciprocal graph at that given point. Obviously not always. Therefore, we know we must have this crossing over indeed at those points. Therefore, that just confirmed to us how to state the number of real solutions to those 2 equations, how many points of intersection, that is going to be those 2. Okay. If we're all right with that in turn, let's just move on to look at one other method that can be associated with points of intersection. This being something called the discriminant. Now, the discriminant is not something that tells you what the coordinates of those points of intersection are. What it does is it tells you how many points of intersection there are. Now, this may be useful if the equations are really complicated and you don't know how to sketch them, or maybe it's part of a larger question where there isn't really room to sketch, or you just want to verify that your sketch is correct. We can use this if the combined equation is a quadratic. We can use it to work out if there are 2 solutions, 1 solution, or no solutions. The formula is b squared minus 4ac. And this may look familiar to you, as it's part of the quadratic formula. Well, what we can say for this is if the b squared minus 4ac is greater than 0, then there are going to be 2 real roots, or 2 real solutions. If it equals 0, then there's 1 real root, 1 real solution, or equal roots, it's the same thing. And then if it's less than 0, that means we're going to have no real roots. Okay. So again, just to clarify if needs be where this a, b, and c are coming from, this is coming from our general quadratic format. So our ax squared plus bx plus c equals 0. So with that in mind, if say we just have this quadratic here that x squared plus x minus 3 equals 0. Well, here the b is going to be 1 because 1 of x. So 1 squared minus 4 times, and our a is also going to be 1. Then our c is going to be the minus 3. So that's the same 1, and then minus 12 was plus 12, so that'll equal 13. 13 is definitely greater than 0. Therefore, we would say that there are 2 real roots. Now, if this was just a quadratic in its own right, then that would just be showing us that there was 2 points upon which this line crosses the x-axis. However, if this quadratic was actually the combination of 2 other lines, let's say it was the combination of y equals x squared and y equals minus x plus 3, so because they're both equal to y, they've set them equal to each other, and then you've moved this right-hand side onto the left side to make that positive x and negative 3. If that was the case, what we're saying by the 2 real roots is that there are 2 points of intersections between these 2 lines. Again, it's not telling us what those coordinates are, but it's telling us how many we should be expecting to find. Well, how else can we apply this, therefore? Well, if we want to look at a question like we have below. So the line y equals mx minus 2 is a tangent to the circle x squared plus 6x plus y squared minus 8y plus 5 equals 0. And we want to find the 2 possible values of m. Well, because we know that these lines are at the very least going to be touching, we know we would be substituting this equation into this equation here, so we could end up with our x squared plus 6x plus, and the whole phrase of mx minus 2 squared minus 8 lots of the mx minus 2 plus 5 equals 0. So expand this, so it's still your x squared plus 6x, but now that'll be plus m squared x squared. Don't forget that they are each going to be squared individually. Minus 4mx plus 4 minus 8mx plus 16 plus 5 equals 0, because minus times minus is a plus here for that. And bring together the like terms. You've got an x squared here and an m squared x squared here. So that's like 1 plus m squared, lots of x squared in total. As for the individual x, you've got 6x here, but then minus 4mx minus 8mx, so together that's minus 12m, lots of x. And then just the numbers on their own, plus 4, plus 16, plus 5. Well, that's going to leave you with plus 25 at the end. Now from here, how would we otherwise work out what m is going to be? What we can say is that because this line here is a tangent to the circle, it's touching the circle but not cutting through it. Therefore, if we just try to picture that, right, wherever it's going to be like, just a line doing this, that's only got one point of intersection. There's only one route between them. Therefore, if we were to take the discriminant of this, we know that it would equal 0. So in this case, your b is the 6 minus 12m, so we're going to square that and do minus 4 times the 1 plus m squared times by the 25, and we know that's going to equal 0. Well, here expanding this, that'll end up being 36 minus 144m plus 144m squared, then minus 100 and minus 100m squared equals 0. Well, bringing that all together, all the like terms, 144m squared minus 100m squared, just going to be 44m squared. And then you've just got your minus 144m left in the middle, because there's no other single m terms. And 36 minus the 100 is going to be minus 64. Let's say we know that equals to 0.